Hello and welcome once again to the Aakash BYJU'S channel. My name is Atiullah and we are live with the percentile booster session for JEE Main 2023. So if you want to be a ranker in JEE Main and Advanced 2023, then this is the place to be. Alright guys, so we are live with the percentile booster series. So we have newly launched this series, and what is the objective of the series? The objective of the series is to look at those low-hanging fruits, those chapters in which we need to put a little bit of effort, but the reward is huge. We are going to take up those chapters. We are going to solve a lot of questions. Some questions would be from previous year JEE Main paper, some questions would be different. The concept here, or the objective here, is one, to make use of these high ROI topics so that you can score very well in these topics, highly scoring topics that is going to boost your percentile. And two, you are going to have a revision of your topics. Okay, if you have forgotten these topics, these are small topics, you might not remember it. So if you have forgotten those topics, I'm going to make sure that this is going to get revised. So we are going to solve questions, but wherever you face any difficulty at all in any formula, in any concept, I am going to explain that in detail, and I'm going to ensure that you understand each and everything. Okay, so don't hesitate to ask anything, even if you think it's a silly doubt, it's something I don't know, it's all right. I'm going to explain that to you. All right, so Dhruv has joined. Good evening, Dhruv. How are you? Good evening, Shivani. All set? Sir, math and chemistry का ऐसा session कब start होगा? Soon, Dhruv. Soon these sessions will start. Okay, as we are approaching closer and closer to JEE Main, the first session of JEE Main, these sessions and more sessions, okay, we have planned so much for you, so that is going to happen soon for all the subjects. Okay, so right now, what is on agenda? On agenda today is heat transfer, another neglected topic, but there are a lot of questions that are asked from previous years, and this topic is extremely simple. I can't tell you how simple this topic is. Even if you don't know anything about heat transfer, you have never heard about heat transfer, I assure you in this session you will understand each and everything. That is my guarantee. Okay, even if you have never heard of this chapter, you will be able to understand everything that we are talking about. Okay, why? Because all you need to know about heat transfer is 80% of heat transfer that we have to study is conduction. Okay, and conduction has a straight analogy from what? From current electricity. So even in your class 10th, you know that V is equal to IR. Do you know that? Voltage is equal to current into the resistance. Do you know that? The series combination of resistors is R1 plus R2 and R3 and so on. The parallel combination of resistor is 1 by R is equal to 1 by R1 plus 1 by R2 and so on. If you know this much also, you will understand everything. That is my assurance. Alright? So enough said, let's dive right into this session and solve some very good questions on this topic and simultaneously revise everything. Okay, just one announcement that there's a 14-day free trial of the Aakash BYJU'S app. Go to the App Store or iPhone Store, download the app and check out the content there. There's top-notch content over there. Okay, chalo, let's get started with this question. Be ready with your notebook and pen because we are going to solve all the questions together, and let's get going with this session. Alright, so what do we have? We have two metal rods, 1 and 2, of same lengths, and they have the same temperature difference between their ends. Okay, so both the rods are between the same temperature difference. So if this is T1, this is T2, then this is also T1 and this is also T2. Their thermal conductivities are K1 and K2, and their areas of cross section are A1 and A2 respectively. If the rate of heat conduction in 1 is 4 times that of 2, then we need to find a relationship between K1A1 and K2A2. Okay, is the question absolutely clear? Chalo. So how do we solve this question? So I'm going to tell you what is the analogy. Okay, what do we say? That the current, I'm talking about the electric current, is equal to the potential difference. What is the potential difference? V is the potential difference divided by R. Okay, in this situation what happens is there is heat flowing through these conductors. Let's say this temperature is T1, this temperature is T2. So heat is going to flow from a higher temperature to a lower temperature, and the rate at which the heat is flowing is called the heat current. The rate at which the charge is flowing is called the electric current. The rate at which heat is flowing is called the heat current. So we can say that the heat current is equal to, and instead of the potential difference, we write the temperature difference, T1 minus T2. Okay, the potential difference would have been V1 minus V2. Here, what is the temperature difference? The temperature difference is T1 minus T2. And then divided by what? Divided by something called the thermal resistance. So do you see the analogy between the two concepts? Okay. What is thermal resistance? Thermal resistance is defined by L divided by Ka. What is L? L is the length of the conductor, K is the thermal conductivity of the conductor, and A is the cross-sectional area of the conductor. Is that correct? Okay. So what do we see? What can we say? We can put all of this together and we can say that the heat current will be equal to what? The heat current will be equal to T1 minus T2. This Ka is going to go upstairs and this will be divided by L. Is that right? Okay. So the heat conduction rate, or we can say the heat current, dq by dt, the heat current is equal to T1 minus T2 into K divided by L. Okay. Now for both these rods, for both these conductors, the temperature difference is the same, T1 minus T2. The length is the same. What does it mean? It means that the heat current is proportional to Ka. Do you agree? The heat current is proportional to Ka. Do you agree with that? So we can make use of this condition. So we can say that the heat current in 1 divided by the heat current in 2 will be equal to K1A1 divided by K2A2. And now it is given that the heat current in 1 is 4 times that of 2. So K1A1 will be equal to 4 times K2A2, and that should be our answer. Yes, Dhruv, we have got the answer absolutely right. Now tell me, if there is anyone who did not know the concept of thermal conduction, are you able to understand this or not? Are you able to follow the analogy? Are you able to understand how we are dealing with that formula? Okay, if yes, give me a thumbs up, give me a yes. And people who already know this concept, this is a good revision for you guys. Is that right? Alright, so if we look at the options, option B will be the right option, and let's get going with the next question. You guys ready? So let's start with the next question. Another simple question, another basic question. Even if you have never learned this concept, never understood this concept, never seen this concept, never heard of this concept, I guarantee you, you will understand it. Okay? Chalo. And this question came in JEE Main 2021. And you will see that it was such an easy question, and people who neglected this chapter, they are neglecting free marks. They are neglecting some very easy marks. Okay, so as I have said earlier also, JEE Main is all about syllabus coverage, and that is what we are trying to do here. Even if you have never studied this concept, in these sessions you will be in a position to solve questions from JEE Main. Okay, chalo, let's see what is this question. There are two identical metal wires. They have thermal conductivities K1 and K2 respectively, and they are connected in series. So you can see this is a series connection. So instead of two thermal conductors, if there were two resistors, two electrical resistors, what will this combination be? This combination would have been, let's say this temperature is T1, this temperature is 2. This combination would have been a series combination, right? And in a series combination, the resistances are added in a straightforward manner. Okay, so for thermal resistors also, R equivalent will be equal to R1 plus R2 if this is a series combination. And what is the unique feature about the series combination? The series combination tells me that the heat current is going to be constant. The heat current is going to be same through the first conductor as well as second conductor. Okay? Dhruv is saying, sir, ये तो simple K1 plus K2 होना चाहिए ना. नहीं ध्रुव, नहीं ध्रुव, नहीं ध्रुव. हड़बड़ी में गड़बड़ी होती है. हड़बड़ नहीं करना है यार, मतलब कोई जल्दी नहीं अपने को क्वेश्चन सॉल्व करने की, अपने को सॉल्व क्वेश्चन करेक्टली करना है। करेक्ट। अब तुम सोचो, नाउ व्हाट यू हैव टू डू इज यू हैव टू रिप्लेस इट बाय अ थर्मल रेजिस्टर R1 R2, ठीक है। यू हैव टू रिप्लेस दिस बाय अ थर्मल रेजिस्टर। या चलो वो उतना ड्रॉ करने की भी जरूरत नहीं है। फर्स्ट ऑफ ऑल टेल मी कि फर्स्ट वाले का रेजिस्टेंस कितना होगा। Now what you're confusing is that resistance is inversely proportional to K. Number one, पहली गलती यहाँ पे है। So R1 is inversely proportional to A. R1 is equal to L divided by K1A. Do you agree? R1 is equal to L divided by K1A. तो जब हम R1 plus R2 जोड़ेंगे तो K1 plus K2 नहीं जुड़ेगा, right? तो ये पहली गलती हो गई। So R2 will be equal to what? R2 will be equal to L divided by K2 into A. ठीक है। What does equivalent resistance mean or what does equivalent thermal conductivity mean? That in place of this we are going to replace it by one rod. We are going to replace these two rods by one rod, okay? And then what will become the length of the rod? The length of the rod is going to become 2L and the area of the cross section is still going to be A. So what will be the dimensions of the equivalent rod? The dimensions of the equivalent rod would be, the length would be 2L and the area of cross section would be A. And let's say its thermal conductivity is K. Then what should happen? Then the current, heat current through this should be the same as the heat current through this. This is the meaning of equivalent thermal resistance. Okay. So what can we say? That the equivalent thermal resistance will be equal to R1 plus R2. And from here what can we say? Okay, for R what can I say? I can say this is going to be L. Now what is the length? The length is 2L, not L. The length now is 2L. Divided by, I am assuming K as the equivalent thermal conductivity and the cross sectional area is going to remain A. So this should be equal to R1. What is R1? L upon K1A plus R2, which is L upon K2A. So A and A gone, L and L gone. So what will be left? You will get K is equal to 2K1 K2 divided by K1 plus K2. Is that correct? Dhruv, समझ में आया कहाँ पे mistake किया? Right? Now are you able to understand this? Is this clear? चलो guys, if this is clear, quickly give me a thumbs up so that you are able to, I know that you are understanding this and you are able to follow. ठीक है? फटाफट give me a thumbs up, give me a yes, so that we can move forward to the next question. But before that, let's look at the options. So option A will be the right option. ठीक है, देखा ये question 2021 JEE Main में आया था. How simple was this question? अगर ये question आपके एग्जाम में आएगा तो is there any chance you are going to miss this question? Yes, there is a chance if you have not studied this chapter. Okay, only under that condition. If you have studied this chapter, even थोड़ा सा भी पढ़ा है, even surface से भी पढ़ा है, even थोड़ी सी भी बात पता है, even if you have attended just this session, you will be able to solve this kind of question, right? So syllabus coverage is very important and we are focusing a lot on that, and hence we have these sessions to give you that edge, that boost for your percentile, right? Chalo, if you think that this is going to help you, give me a like this video and subscribe to the channel if you have not already done, and share it with your friends. All right, chalo, let's now start with the next question. Okay, what is the next question? Next question भी आया, देखो 2021 में आया ये question, and देखना कि ये question कितना simple है. ठीक है? The temperature theta at the junction of two insulating sheets. Okay, so this is an insulating sheet, meaning there is a thermal resistor and this is a thermal resistor having thermal resistances R1 and R2, right? As well as top and bottom temperatures are theta 1 and theta 2. Matlab the temperature at the top is theta 1, the temperature at the bottom is theta 2. Okay, we have to find out what will be the temperature of the junction. What will be the temperature of the junction? Is the question clear? Is it absolutely clear? चलो, तो first of all मेरे को बताओ, ध्यान से देखना और बताना कि यहाँ का टेम्परेचर क्या है? थीटा 1. यहाँ का टेम्परेचर क्या है? थीटा 2. वी नीड द टेम्परेचर ऑफ द जंक्शन. ध्यान से सोचना है इसके बारे में. एंड टेल मी वेदर दिस इज सीरीज कॉम्बिनेशन और पैरेलल कॉम्बिनेशन. ठीक है, क्विकली टेल मी दिस इज सीरीज कॉम्बिनेशन और पैरेलल कॉम्बिनेशन. रेजिस्टेंस जैसा सोचो, रेजिस्टेंस सोचो, पोटेंशियल डिफरेंस सोचो, एंड टेल मी इज दिस सीरीज कॉम्बिनेशन और इज दिस पैरेलल कॉम्बिनेशन. क्या लगता है, व्हाट कॉम्बिनेशन इज दिस? ध्यान से सोचना कि टेम्परेचर ऑफ द जंक्शन की बात हो रही है. दिस इज द जंक्शन, दिस इज वेयर वी हैव टू फाइंड द टेम्परेचर. टॉप का टेम्परेचर इज θ2, बॉटम का टेम्परेचर इज θ1. शिवानी इज सेइंग सीरीज कॉम्बिनेशन. यस, शिवानी इज एब्सोल्युटली राइट. शिवानी इज एब्सोल्युटली राइट. ठीक है, समझो इस चीज को, समझो इस चीज को. पैरेलल कॉम्बिनेशन मतलब क्या? कि बोथ द रेजिस्टर्स शुड बी बिटवीन द सेम पॉइंट्स. अब ये जो R1 है दिस इज बिटवीन θ2 एंड θ, एंड ये जो R1 है दिस इज बिटवीन θ एंड θ1, राइट? तो ये पैरेलल कॉम्बिनेशन नहीं है, दिस इज सीरीज कॉम्बिनेशन. बिकॉज हाउ इज द हीट गोइंग टू फ्लो? द हीट इज गोइंग टू फ्लो लाइक दिस. आई बात समझ में? तो ये कौन सा कॉम्बिनेशन होगा? दिस विल बी अ सीरीज कॉम्बिनेशन. ठीक है, इज दिस क्लियर? यहां पे कोई प्रॉब्लम है? दिस इज अ सीरीज कॉम्बिनेशन. ठीक है, इसमें गलती नहीं करनी है, बेसिक चीजें हैं. ऑलराइट, अगर आपको इसमें थोड़ा कंफ्यूजन है तो कोई बात नहीं, आपका कंफ्यूजन रिजॉल्व हो गया. पैरेलल में क्या होना चाहिए था? अगर पैरेलल कैसे होता वो भी मैं बता देता हूं आपको कि ये पैरेलल कैसे होता. ठीक है, अगर बोलता कि ये जो साइड है दिस इज एट T1 टेम्परेचर एंड ये जो साइड है दिस इज एट T2 टेम्परेचर. In this case, we would have said that this R1 and this R2 are in parallel combination because they are between the same temperature difference. This combination would have been called the parallel combination, but not this combination. In this combination, what is going to happen? The heat current is going to flow same through R1 and R2, and this will be a series combination. Is that correct? तो जब ये series combination है तो अपने को क्या समझ में आ गया? अपने को ये समझ में आ गया ना कि the heat current would be the same through R1 as well as R2. The heat current will be the same between through R1 and R2. ठीक है, what is heat current? Heat current is the temperature difference divided by the resistance. Okay, so let's talk about the heat current through R1. Is this going to be θ1 minus θ divided by R1? Is that right? Is it going to be θ1 minus θ divided by R1? Absolutely. The temperature difference divided by the thermal resistance. And the heat current through R2 is also the same. So what will be the heat temperature difference across R2? The temperature difference across R2 will be θ minus θ2. Remember this, that heat can only flow from higher temperature to lower temperature. Heat cannot flow from lower temperature to higher temperature, just like current flows through higher potential to lower potential. So if we are assuming that the heat current is flowing from θ1 to θ2, in that case θ1 will be greater than θ and θ will have to be greater than θ2, correct? That is why we have written θ minus θ2 as the temperature difference divided by R2. Is that right? Okay. So if we solve this, what are we going to get? We are going to get θ1 R2 minus θ R2 is equal to R1 into θ minus R1 θ2. So this is going to become θ is equal to θ1 R2 plus θ2 R1 divided by R1 plus R2, and that should be our answer. Is that correct? Wasn't this question so simple? So simple, right? Just if you had known this concept, you would have solved this question. This question came in JEE Main. These are free का marks. 4 marks आपको मुफ्त दिया जा रहा है, free, बिल्कुल free. With इतना सा effort, you are getting 4 marks. If you solve a very difficult question from rotational mechanics or SHM or collision, you are still going to get 4 marks. But वहाँ पे effort बहुत ज़्यादा होता है, यहाँ पे effort थोड़ा सा है, right? So nobody is going to tell you all these things, okay? You are on this channel, so you are getting that guidance. You are getting that edge over other people where you are able to understand कि कहाँ मेहनत करना जरूरी है, कहाँ कम मेहनत से भी काम चल जाएगा, right? So you need to optimize that, right? It was simple. It came in JEE Main, and after this session you will be able to solve questions on heat transfer in JEE Main, and that is my guarantee. Okay, so what will be the correct option? Correct option is going to be option A. Clear? चलो next question देखते हैं. Next question also came in JEE Main 2021. So you see that कितना questions आते हैं heat transfer पे. And अभी तक जो जितने questions देखे हैं सब simple questions थे ना, सब बिल्कुल चुटकी बजा के solve करने वाले question थे ना, right? चलो तो ये question भी वैसा ही है, चुटकी बजा के सॉल्व हो जाएगा. ठीक है, जस्ट दैट आपको बेसिक कॉन्सेप्ट पता होना चाहिए, विच अगर आपने आज तक नहीं भी पढ़ा है हीट ट्रांसफर तो इस सेशन में आपको समझ में आ जाएगा. चलो क्या सिचुएशन है? देयर इज अ रॉड CD ऑफ थर्मल रेजिस्टेंस 10 Kelvin per watt. This K is Kelvin. 10 Kelvin per watt and is joined at the middle of an identical rod AB as shown in the figure. ठीक है, फिगर एकदम क्लियर है. तो A, B और D का टेम्परेचर दिया हुआ है. A का टेम्परेचर है 200 डिग्री सेल्सियस, B का टेम्परेचर है 100 डिग्री सेल्सियस, D का टेम्परेचर है 125 डिग्री सेल्सियस. वी नीड टू फाइंड आउट व्हाट इज द हीट करंट थ्रू CD. ठीक है, CD के थ्रू क्या हीट करंट होगा, दैट इज व्हाट वी नीड टू फाइंड आउट. इज दैट करेक्ट? इज दिस क्लियर? इज द क्वेश्चन क्लियर? ओके, नाउ हाउ टू सॉल्व दिस क्वेश्चन. Now the way to solve this question is the way you're going to solve any circuit ka question. ठीक है, what I'm going to do is I'm going to make an equivalent circuit in current and then you'll see how easy it is to solve. ठीक है, let's say I replace these things. This is A, this is B, this is C, this is D. Okay, let's say A is at 200 volt. मान लो A is at 200 volt. 200 डिग्री सेल्सियस दिया हुआ है, तुम वोल्ट मान लो. ठीक है, यहां पे 100 डिग्री सेल्सियस दिया हुआ है, तुम 100 वोल्ट मान लो. यहां पे 125 डिग्री सेल्सियस दिया हुआ है, तुम 125 वोल्ट मान लो. करेक्ट? ओके, अब व्हाट अबाउट रेजिस्टेंस? द रेजिस्टेंस फ्रॉम A to B is how much? It is 10. So the resistance through A to C, how much will that be? It will be 5. And the resistance through C to D, how much would that be? That will also be 5. And the resistance through C to D will be how much? It will be 10. Now can you find out what is the potential of C? Can you find out what is the potential of C? Can you do that? Think about it. What will you apply? If this were a question in current electricity, that's a very simple question in current electricity. If this was the question in current electricity, how will you solve it? Tell me. How would you solve it? What law will you apply? Tell me. What law are you going to apply? It's very simple, guys. Very, very simple. Think about it. Yes, Kirchhoff's junction law. याद है Kirchhoff's junction law? What is Kirchhoff's junction law? The net current going into a junction and the current going out of the junction should be equal. Yes, Shivani is absolutely right. KCL तो लगाना है. And KCL you already know. The current going into the junction should be equal to the current coming out of this junction. Correct? तो फटाफट सॉल्व कर लें क्या? तो फटाफट सॉल्व कर लेते हैं यार. चलो, let's say जो C है उसका जंक्शन का टेम्परेचर है थीटा. Now listen to this carefully. I don't know what is theta. I don't know whether theta is between 200 and 125. I don't know whether theta is between 100 and 200. I don't know anything about theta. In order to see the direction of current, we'll have to assume some value of theta. Is that correct? So I am assuming that theta is less than 100 volt. I am assuming. My assumption might come out wrong. That's all right. No problem there. But in order to get the direction of current right, what we need to do is, so चलो इसको वापस, now that you have understood the analogy, इसको वापस टेम्परेचर बना देते हैं, नहीं तो फिर कंफ्यूजन होगा थोड़ा सा. So theta, what I'm doing is, theta I'm assuming is less than 100 degree Celsius. So I'm just assuming कि theta सबसे छोटा है. In that case, current कैसा जाएगा? इससे current कैसा जाएगा? इससे current ऐसा जाएगा. Let's say it is I1. इससे current कैसा जाएगा? इससे current ऐसा जाएगा. Let's call it I2. और इससे current कैसा जाएगा? इससे current ऐसा जाएगा. Now all the current going into the junction should be equal to what? It should be equal to 0. So I1 plus I2 plus I3 should be equal to what? It should be equal to 0. Is that correct? All the current going into the junction should be equal to 0. That is going to be my approach. यही करते हैं ना KCL में. Alright, so let's write what is I1. I1 कितना हो जाएगा? I1 हो जाएगा 200 minus theta divided by 5, the temperature difference divided by thermal resistance, plus I2 कितना हो जाएगा? I2 हो जाएगा 125 minus theta divided by 10, and I3 कितना हो जाएगा? I3 हो जाएगा 100 minus theta divided by 5, and this should be what? This should be equal to 0. Correct? Can you solve this equation and tell me what is the answer? Quickly solve this equation and tell me what is the answer. तो चलो ये 5 तो ये 2 हो जाएगा, तो ये कितना हो जाएगा? ये हो जाएगा 400 minus 2 theta. So this becomes 400 minus 2 theta minus कितना था? Minus how much or plus how much? Let me check. Plus 125 minus theta, plus 125 minus theta, और क्या हो जाएगा? Plus what else? This will become 200 minus 2 theta. So this becomes 200 minus 2 theta. This is equal to 0. So what do we get? Minus 2 theta minus theta minus 2 theta. 5 theta हो गया ना, तो 5 theta को उधर भेज देते हैं. And 400 plus 200 is 600. 600 and 125 is 725. So theta will be equal to what? It will be equal to 145 degrees Celsius. Is that correct? 125 आता है या 145 आता है? I think 145 आना चाहिए. 717 22 7 4 22 25. 145 आना चाहिए इधर. एक बार कैलकुलेशन चेक करो. Theta should come out to be 145 degree Celsius. Yes, that is correct. तो 145 degree Celsius आ गया. Now what will be the heat current? Very simple. What will be the heat current? The heat current will be equal to the temperature difference, 145 minus 125, which is how much? Which is 20, divided by thermal resistance, which is 10. So this comes out to be 2 watt. आ गया आंसर? आया कि नहीं आया? Was it difficult at all? जिसको थर्मल कंडक्टिविटी पता भी नहीं है, जिसको पता भी नहीं है कभी कंडक्शन उसने कभी पढ़ा भी नहीं है, उसको भी अगर मैं बोल दूं कि भाई बस पोटेंशियल डिफरेंस को टेम्परेचर डिफरेंस ले ले और रेजिस्टेंस को थर्मल रेजिस्टेंस को रेजिस्टेंस ले ले, बस इतना भी अगर मैं उसको बता दूं तो दैट पर्सन वुड हैव सॉल्व दिस क्वेश्चन. है कि नहीं? डू यू अग्री और नॉट? ठीक है, इफ यू अग्री विद दैट गिव मी अ थम्स अप and let's look at the options. The option is going to be option C, 2 watt, and you know that this question came in 2022. कितना easy question था यार, right? चलो, so if this is sorted, if this is clear, then we are going to go to the next problem and we are going to solve the next problem. ठीक है, अभी if you feel that you are, आपका अगर अच्छे से रिविजन हो रहा है, अगर आपका कॉन्सेप्ट स्ट्रेंथन हो रहा है, आपको इस सेशन से फायदा हो रहा है, तो डू गिव अस अ लाइक एंड सब्सक्राइब टू द चैनल, राइट? चलो, आई एम गोइंग फॉर अनदर क्वेश्चन विच केम इन 2022. इसी साल आया है, 26 जुलाई शिफ्ट 2, इसी साल आया है ये क्वेश्चन 2022 में. थिंक सो, देखो क्या क्वेश्चन है. एन आइस क्यूब ऑफ डायमेंशंस 60 सेंटीमीटर by 50 centimeter by 20 centimeter is placed in an insulation box of wall thickness 1 centimeter. The box keeping the ice cube at 0 degrees Celsius of temperature is brought to a room of temperature 40 degrees Celsius. We need to find out what is the rate of melting of ice. At what rate is the ice going to melt? So obviously you can look at the options and you can see that you have to give your answer in kg per second. The rate at which the ice is melting. What is given to us? We have been given the latent heat of fusion of ice and we have given the thermal conductivity of the insulation wall as well. Okay, there is an insulation wall around the ice, but some heat is going to escape because there is a small thermal conductivity of this insulation wall. ठीक है, so it will conduct heat slowly, थोड़ा at a very small rate it is going to conduct heat, which means heat तो conduct करेगा, और heat अगर conduct करेगा तो ice heat lose करेगा. Is that correct? I'm sorry, yeah, आइस हीट गेन करेगा बिकॉज 40 डिग्री सेल्सियस पे है ना, रूम टेम्परेचर ज्यादा है, तो आइस हीट गेन करेगा, और अगर आइस हीट गेन करेगा एट 0 डिग्री सेल्सियस विच इज द फ्रीजिंग पॉइंट ऑफ आइस, देन सर्टेनली आइस इज गोइंग टू मेल्ट. करेक्ट? चलो लेट्स ट्राई टू सॉल्व दिस क्वेश्चन. ठीक है, तो सबसे पहले ये आइस क्यूब बना लेता हूं. Okay, now let's say this ice cube, this is 60 centimeter, this is 60 centimeter, this side is 50 centimeter and this side is 20 centimeter. अब जो भी साइड है उसके अराउंड क्या है, there is 1 सेंटीमीटर का, take any face, okay, ये फेस है, इसके आगे क्या है, 1 सेंटीमीटर थिकनेस का एक कंडक्टर है कि नहीं? There is a conductor of 1 centimeter thickness in front of all of these 6 faces. Do you agree? Can I calculate the thermal conductivity? Obviously, I can calculate the thermal conductivity. But first, what I'm going to do is, I'm going to think that what combination of resistors is this? What combination of resistors is this? Think about it. थोड़ा सोचो. तो ये जो पूरा आइस है ये कितने पे है? ये 0 डिग्री सेल्सियस पे है. और जो रूम है आपका वो कितने डिग्री पे है? 40 डिग्री सेल्सियस पे है. सो थिंक वंस एंड देन टेल मी कि व्हाट इज द कॉम्बिनेशन. इज इट अ सीरीज कॉम्बिनेशन ऑफ रेजिस्टर्स और इज इट अ पैरेलल कॉम्बिनेशन ऑफ रेजिस्टर्स और नन ऑफ दोस? एक बार सोचो और मेरे को बताओ. What do you think? Think about it. Just imagine this is an ice cube. अब इसके ऊपर क्या है? 1 सेंटीमीटर का थिक लेयर है, इधर भी 1 सेंटीमीटर थिक लेयर है, इधर भी 1 सेंटीमीटर थिक लेयर है. ओके, तो इधर कोई भी लेयर ले लो तो अंदर कितना टेम्परेचर है? 0 डिग्री सेल्सियस. बाहर कितना टेम्परेचर है? 40 डिग्री सेल्सियस. ये वाला साइड ले लो, अंदर कितना है? 0 डिग्री सेल्सियस. बाहर कितना है? 40 डिग्री सेल्सियस. ये वाला साइड ले लो, अंदर कितना है? 0 डिग्री सेल्सियस. बाहर क्या है? 40 डिग्री सेल्सियस. सो यू टेक एनी फेस, the internal temperature is 0 degree Celsius and the external temperature is 40 degree Celsius. What does it mean? It means that if you take any face, it is between the same temperature difference. And if it is between the same temperature difference, what is going to happen? This is going to be a parallel combination. It doesn't look like a parallel combination because हमारी आदत होती है कि parallel combination तो ऐसा ही दिखना चाहिए. But ऐसा कोई जरूरी थोड़ी है कि parallel combination ऐसा ही दिखे. ये कहाँ पे लिखा है? Yes, Dhruv, you are absolutely right. ऐसा कहाँ लिखा है कि ये parallel combination ऐसा ही दिखना चाहिए? Parallel combination मतलब parallel lines ही होनी चाहिए. ऐसा कहाँ लिखा है? कहीं लिखा है क्या? नहीं ना. तो पैरेलल कॉम्बिनेशन का मतलब क्या है कि दे शुड बी बिटवीन द सेम टेम्परेचर डिफरेंस एंड यू टेक एनी ऑफ द 6 फेसेस, इट इज गोइंग टू बी बिटवीन द सेम टेम्परेचर डिफरेंस. ओके, तो हीट कैसे एस्केप करेगा? हीट इधर से ऐसे एस्केप करेगा, हीट इधर से ऐसे एस्केप करेगा, हीट इधर से ऐसे एस्केप करेगा, इधर से ऐसे एस्केप करेगा, फिर अंदर एस्केप करेगा और बाहर एस्केप करेगा. यू अंडरस्टैंड दैट हीट इज गोइंग टू एस्केप आउट फ्रॉम ऑल साइड्स. करेक्ट? Heat is going to escape out from all sides. Do you agree? All right. So now what we have to do is we have to do a parallel combination of the resistors. And what is parallel combination? 1 upon R equivalent is equal to 1 by R1 plus 1 by R2 and so on. So if we want the equivalent thermal resistance, this is what we'll have to do. Is this clear? Okay. Now let's try to calculate what is 1 by R1. Okay, let's try to calculate what is 1 by R1. So we know that the thermal resistance is given by L upon Ka. So what will be 1 by R? 1 by R will be Ka divided by L. Do you agree? 1 by R is going to be Ka divided by L. Okay, so what is this going to become? So first let's talk about what? Let's talk about this top ka surface. Let's talk about this top surface. Okay, if we talk about this top surface, तो इसका डायमेंशन कितना हो जाएगा? एरिया कितना हो जाएगा? ये 60 सेंटीमीटर है और ये 20 सेंटीमीटर है, तो एरिया कितना हो जाएगा? 1200 सेंटीमीटर स्क्वायर. Okay, let's say that the thermal conductivity is K. So the area will become 1200 centimeter square. SI यूनिट में चेंज करेंगे तो कितना हो जाएगा 1200 into 10 to the power minus 4 meter square. Is that correct? So this is K into area. Divided by क्या करेंगे? Divided by length करेंगे. अब ये जो मान लो कि ये सरफेस है, मान लो ये सरफेस है, हीट ऐसे एस्केप कर रहा है. So what is the thickness of the conductor over it? What is the thickness of the insulator over it? 1 centimeter thick है ना? देख लो, मैं साइड व्यू दिखा देता हूं. ठीक है, इफ दिस इज द फेस वी आर टॉकिंग अबाउट, इसके बाहर 1 सेंटीमीटर बाहर क्या है? 1 सेंटीमीटर थिकनेस का इंसुलेटर है, एंड द हीट इज कमिंग आउट लाइक दिस. करेक्ट? सो व्हाट विल बी द लेंथ ऑफ दिस insulator? The length is always measured in the direction in which the heat is traveling. So what is the length of this insulator? The length of this insulator is given to us as 1 centimeter. That will be the thickness of the wall. So 1 centimeter को if we'll write in SI units, this is going to become 10 to the power minus 2. तो ये कितना हो जाएगा? ये हो जाएगा 10 to the power minus 2. इससे ये चला गया तो इससे ये कितना बन जाएगा? 12K. Do you agree? So 1 by R1 will be equal to what? It will be equal to 12K. Now these are in pairs, right? These surfaces would be in pair. So if you have taken a surface at the top, if you take the surface at the bottom, it is going to have the same thermal resistance. So I can say 1 by R2 will be equal to 12K. Do you agree? है कि नहीं? अब now let's do what? Let's take this surface. ये side वाला surface में ले रहा हूँ, right? So this is 20 centimeter and this is how much? This is 50 centimeter. तो ये क्या हो जाएगा? 1000 centimeter square. Correct? So if you perform the same operation, 1 by R3 will come out to be what? It will come out to be 10K. Okay? फिर 1 by R4. Take the parallel surface. Take the parallel surface. तो 1 by R4 कितना हो जाएगा? 1 by R4 भी कितना हो जाएगा? 10K हो जाएगा. ठीक है? Is that correct? I'm doing the same operation. R5 कौन सा ले रहा हूं मैं? R5 ये सामने का सरफेस, ये सामने का सरफेस. सो 1 by R5 कितना हो जाएगा? ये हो जाएगा, what is the length? The length is 60. What is the breadth? The breadth is 50. ठीक है? So what is this? This is 3000 centimeter square. We perform the same operation. This is going to become 30K. And उसका जो parallel side होगा, that will also become what? That will also become 30K. Is that correct? सर आई एम हियर इन द सेशन, चीज समझ में आने लगी है. जस्ट वॉचिंग रिकैप ऑफ आइस वाला क्वेश्चन एंड विल कैच अप इन अ फ्यू मिनट्स. ठीक है, नो प्रॉब्लम स्वास्तिका, जस्ट वॉच. ठीक है, नो प्रॉब्लम एट ऑल. ठीक है, यू ज्वाइन वेन एवर यू आर कंफर्टेबल. नाउ इज दिस क्लियर? निधि इज ऑल्सो हियर. गुड इवनिंग निधि, हाउ आर यू? चलो लेट्स कॉन्सेंट्रेट ऑन द क्वेश्चन. चलो, तो नाउ कैन वी कैलकुलेट 1 upon R equivalent? Can we do that? Of course we can do that. 1 upon R equivalent will be equal to 1 by R1 plus 1 by R2. So we have calculated 1 by R1, we have calculated 1 by R2, 1 by R3, 1 by R4, 1 by R5. थक गया मैं. Okay, so I have calculated everything. So let's calculate 30 plus 30, 60. 60 plus 20, 80. 80 plus 24, 104. Correct? Correct. So I can say that 1 upon REQ is equal to 104K. आई बात समझ में? Now what is the rate at which heat is escaping? What is the heat current? Can I say that the heat current मतलब the rate at which the heat is escaping, the rate of flow of heat per unit time. This is equal to what? This is equal to the temperature difference T1 minus T2 divided by REQ, या फिर मैं कह सकता हूं multiplied by 1 upon REQ. I can say this also, मेरी मर्जी. So the heat current will be equal to, what is the temperature difference? The temperature difference is 40 degrees Celsius multiplied by 1 upon REQ. मतलब ये कितना हो जाएगा? Multiplied by 104K. Do you get this? This will be multiplied by 104K. What is the value of K? The value of K is 0.05 and it is given in SI units, so we don't need to do any conversion. Is that correct? Okay. Which means that in 1 second, understand the meaning of this, in 1 second this much amount of heat is being gained by the ice. Heat current matlab heat per unit time. So in 1 second this much amount of heat ice is getting. So how much ice will melt in that 1 second? So in 1 second the ice that is going to melt will be equal to m into L. ये तो याद होगा ना, latent heat of fusion of ice. So Q is equal to ml. So in 1 second, what is the amount of heat that is going to be absorbed by the ice? It is going to be m into L, correct? So this heat that is being gained from the surrounding, ice is going to take that heat and it is going to convert into water. Is that correct? So what do I get? So I get 40 multiplied by 104 multiplied by 0.05 divided by L. What is the value of L? L is 3.4 into 10 to the power 5. This is equal to m. So this will be the mass of ice which is melting per second. Is that correct? Because this value that we have calculated is the heat per second. So this value of m that we are getting is per second. Is that clear? So that will be the amount of ice melting per second. So what will we get? We'll get m is equal to, इसका calculation करें क्या फटाफट, 40 into 0.5 कितना हो जाएगा भाई? 2 हो जाएगा, 2 हो जाएगा, तो 2 into 104 divided by 3.4 into 10 to the power minus 5. Okay, तो ये कितना हो जाएगा? This becomes 1.7. तो ये कितना हो जाएगा? This will become, ये डेसिमल उड़ा देते हैं और इसको कितना बना देते हैं? इसको 10 to the power minus 4 बना देते हैं. ठीक है, तो 104 upon 17 कितना होगा? Approximately 6 point something, correct? 17 5 85, 17 6 672 102 के आसपास, तो 6 point something, चलो 6.1 पकड़ लो. ठीक है, तो ये कितना हो जाएगा? 6.1 into 10 to the power minus 4 kg per second. हाँ, 6.1. It is given as 61 into 10 to the power minus 5 क्योंकि ऑप्शन में वैसा दिया हुआ है. But we have got the same answer, 6.1 into 10 to the power minus 4 kg per second. So that is going to be our answer. So what will be the correct option? The correct option is going to be option B. Is that clear? ठीक है, again ये question कहाँ आया था? ये question आया था 2022 में. तो कौन सा कॉन्सेप्ट है यार? ये सीरीज पैरेलल का ही कॉन्सेप्ट है, उसमें थोड़ा सा कैलोरीमेट्री ऐड कर दिया. If you knew the concept of conduction, was this question difficult? Not difficult at all, right? So if you understood this, you like this, quickly give me a thumbs up. If you understood, clear, everything, all good, give me a like, thumbs up, and then we are going to go to a next problem. तो अभी जैसी सिचुएशन हमने देखी ना, इसी से एक लेवल ऊपर की सिचुएशन हम देखने वाले हैं. And when I explain that question to you, you will understand. Whatever situation we have seen, we are going to go one level up on that question. ठीक है, तो अब ये question JEE Main का नहीं है, ये JEE Main के लेवल से थोड़ा ऊपर है, but अपने को तो लेवल ऊपर ही रखना है ना, राइट? तो चलो ये क्वेश्चन करते हैं. दिस इज अ वेरी नाइस क्वेश्चन, मजा आएगा ये क्वेश्चन करने में. तो व्हाट इज द सिचुएशन? अरे बहुत कहानी लिखी है, मैं कहानी तुमको शॉर्ट में बताता हूं. ठीक है, तो ये जो अपना एक है, इसमें पानी भरा हुआ है. This is a vessel which is filled with water and it has a constant temperature of theta naught. ठीक है, so this reservoir is maintained at a constant temperature of theta naught. Now there is a conductor. The conductor has a length L, area of cross section A and thermal conductivity K. Now what do we have here? We have here m mass of water, water ही है. Here we have m mass of water which is initially at theta 1 temperature. Okay, which is initially at theta 1 temperature. So what will happen? Theta naught is given as greater than theta 1, which means heat is going to flow from theta naught to theta 1. So naturally the temperature of m is going to increase, the temperature of the liquid here is going to increase. So we need to tell that in how much time the temperature of the smaller vessel is going to become theta 2. Theta 2 is still less than theta naught. मतलब the direction of flow of heat is not going to change. The heat is going to flow from the bigger reservoir to the smaller vessel, correct? So we have to tell in what time, right? We have to tell in what time the temperature of the smaller vessel is going to become theta 2. Pranav is saying, sir, happy Diwali, a very happy Diwali to all of you. Obviously after the session मैं आपको wish करने वाला था. So yes, happy Diwali to you Pranav, happy Diwali to everyone. तो have a wonderful but safe Diwali. खूब मजे करना. एक दिन के लिए आप पढ़ाई भूल जाना, ठीक है? आप को एंजॉय करना भी बहुत जरूरी है, ठीक है। सो दिवाली के दिन गाइस डोंट स्टडी, ट्रस्ट मी, दिवाली के दिन आई एम टेलिंग यू एज अ टीचर, एज योर टीचर आई एम टेलिंग यू, दिवाली के दिन कोई पढ़ाई नहीं करनी है। जस्ट फॉरगेट अबाउट studying, spend time with your family, spend time with your friends, have a lot of fun, eat a lot, ठीक है। So do that and take that break that you need. So you have been working hard for so many months, so एक दिन का break बनता है, that will help you come back stronger, that will help you come back better with your preparation. Okay, so Diwali ke din promise me that you're not going to study, you're going to enjoy yourself. That is also extremely important. नहीं तो आपका burnout हो जाएगा और फिर सारी preparation और सारी मेहनत चली जाएगी पानी में. Alright, चलो, is the question clear? Is the question absolutely clear? Pranav is asking, sir, how to clear mains? भाई यही तो तैयारी कर रहे हैं हम लोग. Attend these sessions. आप ये सेशन अटेंड करो, पढ़ाई करो, एग्जाम दो, मेंस क्लियर हो जाएगा. यही तो हम कर रहे हैं, राइट? चलो, ये कोई 2 मिनट नूडल्स बनाने का तरीका थोड़ी ना है कि सर हाउ टू मेक नूडल्स. तो यूट्यूब पे गए, सर्च किया हाउ टू मेक नूडल्स, तो पानी उबाला, उसमें नूडल डाला, टेस्ट मेकर डाला, बन गया नूडल. ऐसा नहीं होता है ना. इट्स अ प्रोसेस, इट्स अ लॉन्ग प्रोसेस. 1 साल 2 साल की मेहनत होती है, कुछ लोगों के लिए 3 साल की मेहनत होती है भाई, राइट? चलो, स्वास्तिका इज सेइंग स्पेसिफिक हीट कैपेसिटी यानी 1 डिग्री टेम्परेचर बढ़ाने के लिए कितनी एनर्जी लगेगी. यस यस, यू आर राइट, एब्सोल्यूट. 1 डिग्री फॉर 1 यूनिट मास. स्वास्तिका, स्पेसिफिक हीट कैपेसिटी, जहां पे भी वर्ड स्पेसिफिक आता है ना, उसका मतलब होता है पर यूनिट मास. ठीक है, जैसे बोलते हैं हम लोग स्पेसिफिक चार्ज, उसका मतलब क्या होता है? चार्ज पर यूनिट मास. वैसे ही जब हम लोग स्पेसिफिक हीट कैपेसिटी का मतलब बोलते हैं, तो पर यूनिट मास ऑफ द सब्सटेंस 1 डिग्री से अगर टेम्परेचर बढ़ाना है तो कितने हीट की जरूरत पड़ेगी, राइट? दैट इज स्पेसिफिक हीट कैपेसिटी. ऑलराइट, क्वेश्चन क्लियर है. उत्तम इज ऑल्सो विशिंग मी हैप्पी दिवाली. अ वेरी हैप्पी दिवाली टू यू टू उत्तम. हैव अ ग्रेट, वंडरफुल, फुल ऑफ हैप्पीनेस, फुल ऑफ फन दिवाली. एंड जैसा कि मैंने बोला, खूब मजे करना. ओके, मिल गया मुझे क्वेश्चन में मास. ओके, ठीक है. चलो, क्वेश्चन क्लियर है ना? तो क्वेश्चन क्लियर है तो हम सोचते हैं. ठीक है, अब हम सोचते हैं. अब इतना तो अपने को पता है ना कि इफ अ मास गेट्स क्यू अमाउंट ऑफ हीट, ms delta theta is, so q is equal to ms delta theta. ms energy has to be transferred, right? हाँ स्वास्तिका, you are right, but थोड़ा सा इसमें कैच है, वो कैच को पकड़ना पड़ेगा. ठीक है, समझो इस चीज को. नाउ व्हाट इज q? q इज इक्वल टू ms डेल्टा थीटा. इतना तो पता है अपने आप को कि q, इफ it is getting an amount of q heat, then the temperature change will be delta theta and they will be related as q is equal to ms delta theta. Is that correct? Okay. But what is happening here? कि you are getting heat as heat current. मतलब there is some amount of heat current that is flowing every unit time, per unit time. So what do we get? So we are getting dq by dt amount of heat current. Correct? Let's say the heat current is dq by dt. In that case, what is happening is, in dt amount of time, dq heat is reaching m. Do you agree with that? Let's say the heat current is dq by dt, correct? And in dt amount of time, how much heat is going to reach small m? dq amount of heat is going to reach. So this dq will be equal to ms, and it is going to increase the temperature by a small amount d theta. Do you agree? dq is equal to ms d theta. Do you agree with this? Okay. Now what is the problem here? That when it attains a little bit of heat, when it gets a little bit of heat, its temperature will increase. Do you agree with that? When it is getting heat, its temperature is going to increase. So let's say पहले temperature क्या था? theta 1 था. So what is the temperature difference? theta naught minus theta 1. And you know that dq by dt depends on what? dq by dt is proportional to theta naught minus theta. dq by dt, the rate of heat transfer, the rate at which the heat is flowing is proportional to the temperature difference. Now when m has received some heat, its temperature is going to go from theta 1 to theta 2, and at every point its temperature is going to change, and at every point if temperature is going to change, dq by dt is not going to remain constant, dq by dt is going to change. Do you get this? जैसे जैसे m को हीट मिलेगा, m का टेम्परेचर बढ़ता जाएगा, तो जो टेम्परेचर डिफरेंस है दैट विल चेंज, एंड इफ द टेम्परेचर डिफरेंस चेंजेस, dq by dt is going to become a variable. Do you agree with that? ठीक है, dq by dt is going to become a variable. इसका मतलब क्या है? इसका मतलब है we'll have to do it in small steps. मतलब यहां पे क्या करना पड़ेगा? यहां पे हमें करना पड़ेगा इंटीग्रेशन. आई बात समझ में? यहां पे हमें क्या करना पड़ेगा? यहां पे हमें करना पड़ेगा इंटीग्रेशन. ऑलराइट, समझो इस चीज को. सो आई एम अज्यूमिंग दैट एट अ पर्टिकुलर टाइम theta is the temperature of this liquid. Okay, what is the temperature? The temperature is theta. So can I say that dq by dt at that instant the rate of heat flow will be equal to what? It will be equal to Ka into theta naught minus theta. At this instant, what is the temperature difference? The temperature difference is theta naught minus theta. So Ka minus theta naught minus theta divided by L, this will be the heat current. So Swastika is saying AK theta naught minus theta divided by L is equal to heat current would have been the expression had it remained constant. Yes, Swastika, you are absolutely right. Spot on, bang on. If it would have remained constant, okay, this expression dq by dt, which is Ka into theta naught minus theta divided by L, would have remained constant, and in that case this would not have been a very good question. That would have been an ordinary question. But what makes it a brilliant question is that it is not going to remain constant and we'll have to use integration. But जो main understanding की बात थी, that is done. So what is dq by dt? dq by dt is Ka theta naught minus theta divided by L, which means dq is equal to what? dq is equal to Ka by L into theta naught minus theta multiplied by dt. So in a small time dt, dq amount of heat is being transferred from the reservoir to this small container or this small vessel. And this dq is going to change the temperature of this vessel by d theta, which means dq will be equal to what? dq will be equal to ms d theta. Do you agree? dq will be equal to ms d theta. So this expression we can equate it with ms d theta. So let's do that. So this becomes Ka divided by L theta minus theta naught minus theta into dt is equal to ms d theta. Correct? So this is going to become what? This is going to become Ka divided by msl into dt is equal to d theta divided by theta naught minus theta. Now you understand what do we need? We need the temperature as a function of time. Correct? You understand what is the end goal? The end goal is to find the temperature as a function of time. So temperature और तो टेम्परेचर थीटा को और टाइम को मैंने सेपरेट कर दिया, एंड यू नो दैट आई एम गोइंग टू इंटीग्रेट इट. सो एट टाइम इज इक्वल टू 0, व्हाट वाज द टेम्परेचर? द टेम्परेचर वाज थीटा 1. एट टाइम t is equal to 0, what was the temperature? The temperature was theta 1. At time t is equal to t, the temperature will become theta 2, and we need to find out when the time becomes or when the temperature becomes theta 2. We have to find the time when temperature becomes theta 2. Now this is simple integration. Ka upon msl, this is a constant, comes out, integrate dt, you are going to get t. This will be equal to इंटीग्रेशन ऑफ डी थीटा अपॉन थीटा नॉट माइनस थीटा. ये क्या हो जाएगा? ये कौन सा फॉर्म है? ये हो जाएगा ln थीटा नॉट माइनस थीटा, लेकिन विद अ माइनस साइन. सो दिस विल बिकम माइनस ln थीटा नॉट माइनस थीटा, एंड वी हैव टू पुट द लिमिट्स फ्रॉम थीटा 1 टू थीटा 2. And if you do that, you are going to get Ka upon msl multiplied by t is equal to ln. You put the limits, नेगेटिव साइन हटाओ, लिमिट को इंटरचेंज कर दो, तो ये बन जाएगा थीटा नॉट माइनस थीटा 1 डिवाइडेड बाय थीटा नॉट माइनस थीटा 2. Is this clear? Right? So यहां से टाइम कितना आ जाएगा? यहां से टाइम आ जाएगा, take everything to the right hand side and it will come LMS upon Ka into ln theta naught minus theta 1 divided by theta naught minus theta 2. Is that correct? Did you get this? Did you understand this? If you understood this, quickly give me a thumbs up. Swastika बोल रही है आ गया मेरा भी. Excellent. Very good. So the thing in this question was कि you have to, the idea that you will have to integrate, the idea that the heat current is not going to be a constant, it is going to be a function of the temperature difference, and the temperature difference is not going to be a constant, it is going to change. So that concept or that understanding would automatically lead you towards integration, right? And once you figure out that you have to integrate, then it is simple mathematics. Ab is stage mein you don't I don't think you have a lot of problem integrating, right? But that idea, that is important, and that is what we are trying to understand. Adarsh is saying Jai Hind sir, Jai Hind Adarsh, okay? And wish you a very happy Diwali as well. Have a great Diwali, खूब मजे करना, खूब enjoy करना. All right, तो चलो, let's look at the option. So option A is going to be the correct option. So now I'm going to wrap up this session. जिन लोगों का सेशन मिस हो गया था बीच में, जिन लोगों ने देखा, एक बार शुरू से देख लो. हीट ट्रांसफर का 80% आपका सॉल्व हो जाएगा विद दिस सेशन इटसेल्फ. ओके, तो चलो, आई एम गोइंग टू wrap up this session over here, and I'm going to see you again on Wednesday with the rankers batch. Okay, so I'm going to see you there on Wednesday, and in the meanwhile, have a great Diwali, have a wonderful Diwali, खूब मजे करना, and have a lot of fun. All right, so till then, keep practicing, keep getting better, and happy Diwali.